So you had to come up with the equations given the parameters that they gave you. You tell me if there's any questions. I'll just kind of walk through and you tell me if you have any questions, if you didn't get the equation. I basically always use the graph to show me where I am, to see where my major axis is. You don't have to, I mean, you could connect the dots if you like to. So your goal is to just get to the equation. And again, if you take b squared without doing b, all you need in here is b squared. You don't have to find b. Remember, when they give you the major axis length, you're going to divide it in half, because it's the distance from the center to the endpoint and to the other endpoint, so it's the whole thing. The passes through probably takes a little bit longer. And again, you don't have to find b, just get b squared in here. Don't leave your fraction in your denominator. Just flip it. You use your keep, change, flip. Keep the top, change, and flip. So it's going to be 21 over 400. You can't leave a fraction in a denominator because this makes it a complex fraction. So as an answer, you have to flip it over. When you're looking for a and b, then you're going to have to bring it back down, because this is a. This is a. Is it bigger? Well, whatever it is. You have to bring it back down to figure out your square root 1. And it's not pretty, but you really didn't need to worry about that because you were leaving everything squared. When you don't have to take the square roots, don't leave everything square, because that's what you're putting in there. You okay with this one? Vertex and covertex, those are nice. You can find your centers from there. A minor axis of 2, so there's your minor axis. Your b is 1. Major axis is your a, minor axis is your b. And again, all you're looking for here is just your b squared.
Can you scroll back up to 29?
Mm-hmm. Get the average of the x's to find the center. The y's going to stay the same. Good?
Yeah, I didn't see it before.
No problem. Minor axis again is your b. 35 was a little tricky. They just gave you a couple of little things to figure out. So once you found out c, you can find your a, and then you can find your b. And all you need again is your b squared. Find a and then find c. That's it? Yeah. This is not so bad. Your hyperbola. Let's take a look at the couple of differences between the hyperbola and the ellipse. Okay, take a look at them and tell me some differences. What do you spot?
They look the same except for the subtraction.
Okay, subtraction. Now, compare the left side to the right side. What else is different? What changes?
The y and the x.
The y and the x. Oh, thank you. The y and the x change this time. Because look, a and b stays the same. Because in a subtract, it matters who comes first. So when we do a subtract, a will always be the first one. X and y will interchange depending on who's the major axis. Okay, now, We write covertices, however, this really doesn't have covertices. Did I give you a graph on yours? No. When we do this, your hyperbola, if the x comes first, it's going off the x, whether it's translated or whatever. It'll never be slanted. We'll do it off the x translated or off the y translated. And this guy will come off the y. They're like two little parabolas. And how we graph these is we start with a box. Almost like when you make an ellipse, but instead of making it oval, we make a box. So technically, this is a vertex, this is a vertex, this is a covertex, but it doesn't sit anywhere near your hyperbola. But we need it to make these guidelines, these transverse lines. So we technically have to put a covertice there, but we don't really technically call it a covertice because it doesn't sit on your hyperbola. We just need these to make a guideline for this. We need to make those asymptotes. And as you've seen before, whenever we have an asymptote, any restrictions in your denominator, even in trig, your asymptotes for like your tangent curve, it never touches the curve. So we kind of use this as a guideline. And we'll talk about this. And what else do you notice? Anything else different? This guy's a plus. This guy's a plus because now watch what happens. Before, our foci were inside your ellipse. Now, your foci are outside of your hyperbola because the rule of the parabola, the focus comes inside the parabola. So now they're outside of it. So therefore, we add them, not subtract. So that's another difference that we have to look at. And then we have this sweet little formula down here that looks horrible again. It's an asymptote. When you make your box, you have to make these little transversals, these asymptotes, and this is the equation of your asymptotes. However, it's very, very simple. This is your y minus k. Your y minus k, whatever y minus k is. This is your x minus h, whatever x minus h is. This is the slope, the change in y over the change in x. So it's really simple to remember it. And it's whatever's under the y, square root, whatever's under the x, square root. The change in y over the change in x. That's your slope. So that sets up kind of nicely. So let's try one. Now, what's different from when we did the ellipse? And we completed the square with the ellipse.
Both variables have squares.
They have squares.
No, there's no another variable.
There's a missing variable, which means one of the vertices has to have a 0, right? One of the part of the center has to have a 0. But what else is different? An ellipse was really like a circle, a subtract. So your ellipse had all pluses in here. And we said it could never be negative on the other side if it was an ellipse. But a hyperbola has a negative. So again, gather your parts. Hello, my latecomers. All right, so group them together. Yeah, my board's gonna act up. So there's only like one square to complete, right? The y part of the center, and again, the center is not inside the hyperbola either. So let's factor out 4. This is the same as y minus 0. So it's half of 2. And multiply it by the 4. 4. Okay, now we know we can't have it equal, you got it? We can't have it equal to a negative. It has to be equal to 1. Both of your formulas are set up so that they're equal to 1. So, an ellipse always has everything positive. If we were doing an ellipse and something came out negative, something went wrong. But in a hyperbola, we get one negative, so that the negative eventually will come in the middle. So we're going to divide everybody by a negative 12. What is going on here? Notice what's going to happen. This x term now is going to become your negative. So I'm just going to put it over here and switch it around if it's okay with you guys. So 4 goes into 12 3 times. And I'm just going to move this one here because that's going to be your positive. So it kind of looks similar to an ellipse again. But it has the subtract in the middle.
So if you didn't move it, it would be negative x plus y squared over 3 plus y squared?
Yes, but you want to set it up like a hyperbola with the subtract in the middle. Because the major one has to come first.
Okay.
So this, if you left it the other way, then your minor one is first. So it has to be set up in this format. If you take a look at the format that I gave you on the note page, it's got to be this way. The subtract has to come in the middle because we say that the first one is the major one. So this is going to be your a squared. This is going to be your b squared. So what's the center of this? Negative 1, 0. Good. The x still goes with the h no matter where it's located. The k still goes with the y. Okay. I always like to make sure that I say everything that I needed to say. All right, we can find c squared. We'll find c squared in a minute. We'll do your a squared plus b squared first. So what's a? 2. What's b? Okay, and so let's find c squared. Remember, c squared is the plus. It's got to come outside that box. So c squared gives us 4 plus 3. And c squared gives you 7, so there c gives you radical 7. And c has to be the longest one. It's like Pythagorean theorem, where c is the longest side. Okay, so you're going to start your sketch. You're going to find your center. Remember, it's a translated center, just like the other one. Okay. Now, your major axis is the first one. So your major axis is the y, which means your hyperbola is going to go off the y, up and down. So we're going to go up 2 and down 2. This is the vertex. So give me a point of your vertex. Use the center. Your center is negative 1, 0. So if I go up 2, where am I? Negative 1, 2. If I go down 2, where am I? Negative 1, negative 2. Now we're going to find your covertices, but they really don't exist as covertices, but we need it to get this box. So we're going to go over radical 3. Radical 3 is a little less than 4, which would be 2. So it's somewhere like, it is 1.732, but it's somewhere a little bit less than 2. So it's going to be over on this side, right here, right here. You don't even have to name them if you don't want to, but it's easier to just make sure that you graph them. So now we just make a box. Through this box, we catch the corners and make a transversal. And to draw this, you start with your vertex point and you make like a parabola. Use your box and your asymptote as a guideline. Come close to it, but don't touch it. So off the vertices is your parabolas, 2 little parabolas. your foci points fall inside here. Now, since your foci is a radical, all you really have to say for your foci is just take your -1 and plus, because we're at 0, plus or minus radical 7. Radical 7 up, radical 7 down. Make sense? Okay.
How do you know how far over you go with your box?
Well, I kind of estimated. I said radical 3 is a little less than radical 4, which would be 2, right? So if this was at -1, 0, I just want to get a position that I'm a little bit more than 1. So it's not going to be to the left of my origin. It's going to be a little bit to the right of my origin. I just estimate. It's just really a sketch. And your covertices, you technically don't need them. We don't call them covertices, but we do need them to complete the box. So we kind of just get a feel for where it's going. Now, here's how you make your asymptotes. We're going to use that formula. The y minus k part is the y minus 0, isn't it? I'm just going to put y minus 0 for now. Plus or minus the slope, and here's your x part. So start with your y minus whatever, your x minus whatever. Take those right from your formulas, and then put your slope in here. Change in y over change in x. So go to your y and take the square root of 4, which is 2. Go to your x, underneath, take the square root of 3. And remember, the nice part about this, we don't have to rationalize. And all you have to do now is just simplify this equation. If there was something here other than 0, I would add or subtract it to the other side. I got to get a y equals, because it's the equation of a line. Since it's 0, I just need to say y equals plus or minus 2 over radical 3, and just leave it like this. Don't distribute or anything else. This is your asymptote. If this was said like y minus 3, I'd have to add 3 to the other side. Okay? Both sides. Your covertices we don't need. We just need them to make the box. Good? Not that much difference. If the minus has to come in the middle, and because the subtract makes a difference, who comes first? The major axis will come first. And your c squared and a squared plus b squared is now a plus instead of a minus. And it makes sense because instead of making your foci inside this box, you want it outside this box. So it makes sense to add, not subtract. All right, ready to try another one? Oh, did I only give you one? Oh, I can? I thought I had 2 of them here. Oh, I guess you can start your homework then. How's that?